Alright, so now we're moving on to section 10.3, where we're going to talk about polynomials. And in a sense, we've been talking about polynomials this whole time. So let's take a look at the evolution of the types of functions we studied. When we started talking about functions, at the very beginning of the course, we started talking about things that look like that, say. And these are linear functions. We have a constant term here, and a x to the first power, we can think of that here. And really, even the constant term we could think about as 3 times x to the 0. X to the 0 is 1, so this is still a good old linear function. And so we had x to the 0 plus stuff like x to the 1. And then earlier we talked about quadratic functions, which is what happens when we add in x squared terms. And so this coefficient can be as large or as small as we want, and it can be positive or negative. All of that gives us a function of some sort. And so these are all a subset of a more general family of polynomials or functions called polynomials. Now, what polynomials are any function that can be written this way with x to the zeros, x to the first, x to the second, or really any x to the powers at all. So you could do something like that, and you can make the coefficients here 0 if you want. So that would be something like that. I can add in x to the fourth terms. I can add in x to the 11th terms if I want, as long as I have a sum of x two powers to whole number powers plus or minus some coefficient in front of them. These things are all called polynomials. Now, as you might imagine, polynomials are a lot more complicated than linear or quadratic functions, but the study of linear and quadratic functions will help us recognize what's happening with polynomials. So, the first thing we're going to talk about is the shape of polynomials. And so what we're going to do is we're going to graph together some basic kind of shapes here. Y equals x squared, or y equals x squared, y equals x cubed, y equals x to the fourth. And so what we notice here is that some of these polynomials go to positive infinity in both directions, and some of these polynomials go to positive infinity in one direction and negative infinity in the other direction. And so if we want to examine which polynomials go to positive infinity in both directions and which ones go to the negative, let's see, blue and orange are the ones that go positive in both sides, and they are the polynomials with even degree powers. And this makes sense, right? X to the fourth is the same thing as x squared squared. And we know that x squared is always non-negative, so if I raise that to any power, it will also always be non-negative. So x to any even power will always go to positive infinity in both directions, whereas x to some odd power will always go to positive infinity in one direction and negative infinity in the other.